Dear students, let us we study the topic Borazole and carboranes. In my earlier class, I have told you about the diborane, its method of preparation, properties and the structure. Boron forms some interesting inorganic compounds with nitrogen. The most important one is borazine with the chemical formula B3N3H6. It is a colorless volatile liquid. It is also called borazole. Borazine is prepared by heating together boron trichloride and ammonium chloride. The initial product formed is trichloroborazine, which on reducing with sodium borohydride yields borazine. 3BCl3 plus 3NH4Cl gives B3N3H3Cl3 plus 9HCl. This chloroborazine, when it is treated with sodium borohydride, gives borazine, diborane and sodium chloride. Borazine is also formed by the interaction of diborane and ammonia at 200 degrees centigrade. During this reaction, along with borazine, hydrogen is also evolved. The borazine resembles benzene. Hence, it is also called inorganic benzene. The question arises, why borazine is called inorganic benzene? It is due to the following reasons. The structure of borazine is similar to that of benzene. In borazine, each boron atom and nitrogen atom are sp2 hybridized like carbon atoms in benzene. Each nitrogen atom has one lone pair of electrons, while each boron atom has an empty p orbital. Boron, the Bn pi bond in benzene is a dative bond, or it is also called coordinate bond, which arises from the sidewise overlap between the filled p orbitals of nitrogen atom and empty p orbitals of boron atom. It is similar to pi bond in benzene, which is formed by sidewise overlapping of two p orbitals of two carbon atoms. In benzene molecule, C double bond C bonds are non-polar, while in borazine, due to the difference in electronegativities between boron and nitrogen atom, Bn bond is polar. Borazine is isoelectronic with benzene. It means it contains the same number of electrons. To substantiate this, in case of benzene, the two carbon atoms link together. Each contains 4 electrons, hence the total number of electrons is 8. In case of borazine, nitrogen is linked to boron. Nitrogen atom contains 5 electrons and boron atom contains 3 electrons, 5 plus 3, total 8 electrons. Like benzene, borazine is a colorless liquid. Because of the similarities of structure of borazine, it is also called inorganic benzene. Now coming to the structure of the borazine, I have showed here, and it is also having the similar resembling structure with benzene. Both have the same structure. In case of benzene, all the corners are having carbon atoms, and in case of borazine, so it contains boron, nitrogen, and so on. Now coming to the structure of borazine. Now in case of the structure of borazine, the BH bond length is 120 picometer and NH bond length is 102 picometer. This shows that BH bond length is greater than the NH bond length. And in the ring, NB bond length is 144 picometer. Coming to the bond angles, now NBN bond angle is 117.1 degree and BNB bond angle is 122.9 degree. Borazine is having sp2 hybridization, and here the difference in bond angle, if you add the two and then take the average also becomes the bond angle 120 degree. Let us compare this with benzene. In case of the CC bond length in benzene is 142 picometer, whereas in case of borazine it is 144 picometer. In case of benzene, it is also sp2 hybridized and the bond angle is 120 degree. Coming to the resonating structures of borazole. So the resonating structure is given, and here it shows that the nitrogen is having a lone pairs of electrons while the boron is having an empty p orbital. The borazine is more reactive than benzene. Now let us study why borazine is more reactive than benzene. It is because of the following reasons. Coming to the first one, borazine is more reactive than benzene towards electrophilic aromatic substitution reaction because borazine is highly polar molecule due to high electronegativity differences between boron and nitrogen atom. This situation we don't come across in case of benzene because benzene contains the same carbon atoms. The pi bonds in borazine are highly polarized than pi bonds in benzene. Hence, borazine is more reactive than benzene. Benzene undergoes only substitution reactions, whereas borazine undergoes both addition as well as substitution reactions. This is about the borazines. Coming to the another called carboranes. Carboranes are electron delocalized clusters composed of boron, carbon and hydrogen atoms. Some of the carboranes also contain other metallic and non-metallic elements in the cluster framework. The general formula of carborane is C2BnHn+2, where n is an integer ranging from 3 to 12. Here I am showing the position of carbon in carboranes. Based on the position, these carboranes are also classified into three categories called orthocarborane, metacarborane and paracarborane. In orthocarborane, the two carbons are ortho position with respect to each other. In case of meta, it is the 1,3 positions, and in case of para, they are opposite to each other. These carboranes are also classified into another categories called closocarboranes, nidocarboranes and arachnocarboranes. Coming to the closocarboranes have closed triangulated polyhedra structure. The general formula is C2BnHnN+2. Total number of electrons in bonding framework is 2n+2 electrons or n+1 electron pairs. Example is 1,6C2B8H10. Coming to the The next one, that is nidocarboranes. These nidocarboranes have the one corner of triangulated polyhedra is removed. In case of nidocarborane, one corner of triangulated polyhedra is removed and its general formula is C2BnHn plus 4. The total number of electrons in bonding framework is 2n plus 4 electrons or n plus 2 electron pairs. The example for this is C2B4H8 or 17C2B9H12. Coming to the third category of the carboranes called arachnocarboranes. In arachnocarboranes, two corners of triangulated polyhedra is removed. So the diagram is showing the the polyhedra, the positions are removed. General formula of the arachnocarboranes is C2BnHn plus 6. The total number of electrons in bonding framework is 2n plus 6 electrons or n plus 3 electron pairs. Now, the example for this is C2B7H13. So, this is about a short note on carboranes and the borazine. Thank you.